Okay. Are there any questions on the spreadsheets, on what we did on Wednesday? Okay, then let's, I need to get mine up. Okay, it should have been, let me take a minute to find it. Okay, again, the idea of the spreadsheet is to, you know, follow every, what happens during a time period. I always have a bad throat as soon as I start talking. Okay, no questions. Then what we need to do is talk about the last two columns. Okay. If we were to stop here, what would be our estimated cycle time? We're running the simulation for two purposes. One purpose is to get average cycle time per customer, and the other thing is to get the average number in the system. Okay. If we wanted to get the average number, the average cycle time per customer, what would be our current estimate? Any ideas? If you look at this, if you look at my data, I guess we should have the same data. If we look at the data, what would be our estimate of the average cycle time per customer? Yes, 12. Yeah, I don't think, you know, I'm not sure I remember everybody's name. Let me make sure I remember everybody's name. I'm going to stop this. Okay. In other words, in order to estimate the cycle time, that's the purpose of this column. We take the sum of that divided by 2. Okay, and that's our estimate of cycle time. Now what we need to do is get an estimate for the time in the system. This is much more complicated. Because it's complicated, you'll need to look up here instead of at your computer screen for a minute. There we go. Okay, if I were to plot, oops. And what I'm going to do is draw a graph of the number in the system versus time. Okay. So we're going to look at number in system versus time. So let's say we started with an arrival. The arrival stays, and maybe that arrival leaves. And we get another arrival. It stays for a while. We get another arrival. That arrival leaves. Maybe the system looks like this. And that's the end of our simulation. Okay? To get the average number in the system per unit time, that is really a time averaged value. Okay, there are two ways we're going to get estimates within a simulation. One is a sample-based estimate. The sample-based estimate is we just take a random sample of the data points, we sum them up, and we divide by the total. Right? That's kind of what you're used to doing. Right? An estimate for the mean is the sum of the x's divided by n. I call that a sample-based estimate. Kind of think of it as a tally. If you have a tally where you're adding things up, and then you divide by the total number of data points. That's what you're used to. Another type of average that is very common in a simulation is a time average value. Right? The reason for a time average value, let's say the number in the system. Let's say the number looked like this. Let me make another plot. Let's say right, if you just looked at the data samples, you know, first you have 0, then you have 1, then you have 0, then you have 1. So you say, well, 50-50 chance. If you just look at the data, you got as many zeros as you have ones. But in fact, the system is mostly empty, right? So that's why you can't just take a sample-based average. You can't just look at the data itself, okay? You have to consider time, okay? So that's why we're looking at this. We're going to have to take a time-averaged value. What you do for that is you take the area under the curve and divide by the total time. Okay, a time average value, you simply take to get an averaged estimate is the area under the curve divided by the total time. Okay, so basically what that means is every time an event occurs, remember we have two types of events. There's an arrival event and a service completion event. What happens is every time that event occurs, we look backwards and add the most recent area to it. Okay, let me demonstrate. Here we have a service completion. Okay, we look at this area and we'll keep a running total accumulation of all these areas. Every time an average, okay, there's along this axis, this is a number, and this is time. Right? So every area, whenever something happens, we're going to look backwards and add how much area was added to our sum. Okay? The area is always, the amount of area here is always the number, that's the height, times the width, which in this case is the time. Okay? So let's go back to our spreadsheet. That's what columns K and L are. Okay? K is the area. Remember, the area is the time, that's the width, divided by time, multiplied by the number. Okay? So let's see, we always start at 0. Okay, at time 0, this is going to be 0, and the accumulation, oops, that's a O. 0, 0. Okay. At time 11, okay, we look backwards in time and add that little bit of area. Okay, the area is the time interval. We had 11 time units, times the number, which is 1. So we're going to add 11, and of course the accumulation is 11. Okay, so that takes care of that column. Okay, now let's see, the next time is at time 12. At time 12, what happened? What's the event? An arrival. Okay, so an event happened at time 12. We look backwards and figure out the area that was added to our curve. The time interval is what? What's the time interval? 1. Okay? What's the number in the system? We're looking backwards. What was the number over that 1? 0. Okay? 1 times 0 is 0, and our accumulation then is 11. Every time an event occurs, we're going to look backwards in time and add that bit of area. Okay, the next time is 24. The time interval is what? 12 multiplied by 1. So we add 12 units, and the sum is 11 plus 12 is 23. Okay, the next time unit is 25. So how much area are we adding? What's our time increment? 1. Time increment is 1. What's the number that was there during that one time interval? Okay, 2. 1 times 2, so we're going to have to add 2. And we get accumulation of 25. Finally, we stopped our simulation at time 36. Let's see, so that means we had a time interval of 11, I get 25 minus 30, that's 11. Okay, 11 times 1 is 11, and our sum of our time is 36. Okay. Let's say that I wanted, my goal before I started, I said I want to run this simulation for 40 time units. Okay. That means we actually have another type of event. When we did this simulation, we had 2 events. We had arrival events and service completion events. Okay, let's add a third event, and that's a stop event. So at time 40, we're going to finish this off. At time 40, we have a stop event. Okay, we don't have to worry about in-arrival times or anything. Nothing leaves. So what we're going to, but that's if we run it till 40, we look backwards in time. What's the time interval? What's the time interval? 4. Okay, how many were in the system during those 4 time units? 2. So we're going to multiply 8. So this gets us the area of 8, and 36 plus 8 is 44. Okay. Okay, so if we wanted to get the average number in the system, our estimate for the average number in system is equal to the total area divided by the total time, slightly more than 1. Okay, so that's the way we that's a time averaged value. Okay. It seems pretty clear now, but my experience is halfway through the semester you're going to be confused in the difference between time-weighted averages and sample-based averages. So keep this example in mind. Okay, we are now ready for the lab. Let me pass it out, then we can talk about it. Okay, yeah, let's talk about it for the distance learning students. If you could read over the lab first, and then listen to what I have to say. Okay, I think it's pretty straightforward. It's very similar to what we've just did in class, with a couple of differences. What's the first difference you see between this and what we did in class? Do you see any difference between this and what we did in class? Yeah, that's the major difference between what we did in class and this one. This has a random arrival time. So whereas before I just had 12 for the arrival time, here you're going to have a random number. Okay, and we're going to use the Excel function for the random numbers. Okay, and so I've listed those. We'll talk, you know, the first one is really just going to be a uniform distribution. The second one turns out to be an exponential distribution. Although it uses logarithm, it turns out to be an exponential distribution, and you'll see that in a couple weeks. But for now, don't worry about where they come from. Just use the Excel functions. So everybody will have slightly different spreadsheets since it's random. What else? I guess everything else should be clear. Why don't you start working, and then you'll discover where the questions are. Okay, let's see. The question is, with respect to the generation of the random numbers, you would have two ways to do that. You could generate a random number somewhere off the spreadsheet and just hit the F9 key, and every time it'll recalculate it, then copy it. What I would do, you know what? That might be a good idea. That's a good idea. I think that's what I would suggest doing. I wasn't going to, but it's better than what I was thinking. What I was going to do, you could just stick a random number here and do something like is equal to RAND. The trouble is, every time you go to calculate another random number, notice that was 0.48 before, now it's 255, so you know, all your numbers are going to be messed up. So your suggestion's a great suggestion. I should have thought of that ahead of time. So over here, what I would do is off the spreadsheet, you might have arrivals. And the arrivals is equal to minus, no, it's, what's the arrival? Oh. Okay. Okay, so there's an inter-arrival time. Go ahead and generate it, and then take this number. 2 decimals is fine. So then over here, inter-arrival time, except you got to have a better memory than mine. I've already forgotten. 1.57. 1.57. There, now it's not going to change. That would be a good way to do it. Otherwise, your spreadsheet's going to be pretty volatile. And then the same thing for services. Boy, there's that feedback, isn't it? It's kind of irritating. Maybe it's because I left. Okay, services, minus, equals minus log random. There, that'll work for services too. Okay, other questions? Okay. By the way, on the labs, feel free, these are not, labs are not tests. Labs are your opportunity to learn the material. So you can talk to each other, you can look at each other's computer, talk to Ben. If I'm in the room, talk to me. I don't care how you finish the lab, as long as you understand what you're doing. You know, what's going to happen, I predict on the test, is some people are not going to do very well on the test. And the reason's going to be they subconsciously depended too much on somebody else in the labs. Okay, but you're the only one that can judge that. So when you put it in the computer yourself, make sure you understand what you're doing and not just copying somebody else. But, you know, so you talk to each other, whatever you want to do in order to finish the lab. I had another interesting suggestion. This will also work. Sort of a suggestion. Okay, we have arrivals here. That's 2 times the random number. We have services here. Oops. Thank you. Turn the screen on. I guess I have to wait a minute. Okay, we have, basically the concept is we can generate our stream of random numbers and then use them when necessary. Okay, if you don't want to hit the F9 key every time, here we have arrivals. That's 2 times random number. Here we have services, minus log times random number. I'm going to copy those down. Okay, so now I have a whole bunch. I'm going to hit Control D, Control D copies them down. So you see these are all, in fact, I'm going to make them more readable. Okay, so these are now a stream of random numbers. Now, of course, I have the same problem. Every time I do a calculation, it's going to change them. So what we could do is, if you're positive you have enough, you could hit the copy, okay, and then paste special values. So now I have fixed my stream of random numbers, okay? And so when I use this number, my first random number is 1.12 for inter-arrival time. I'll just say 1.12. You know, and then next time, so that one's been used. Next time I need one, I'll use 0.89, etc. And that would be another alternative way to do it. Just have this stream and use them as you need them. Actually, conceptually, this is kind of the way simulations work. We have this stream of random numbers, and we use them up one at a time. Okay, good observation.